Pigweed here. Today we review Ruby Redbird and ask, was there anything before the Big Bang? Okay.
Hey, good to see you.
Good evening.
All right, how about some beer and conversation?
Well, that's a good idea. What are we drinking?
Well, this crazy Ruby Redbird.
Okay, never heard of it.
Yeah, all right, very good. So what's on your mind?
So I had to go get a oil change this weekend, and I didn't bring anything to read. And I got in there, and there were some magazines on the wall, but right there to my left was the Watchtower.
Ah.
Yes, there were several issues there, and I must have picked up issue number 1.
Okay.
Because it was, who is God?
Yeah.
You know, what's his name?
Yeah.
And where did God come from?
Yeah, for our listeners, the Watchtower is the printing house of the Jehovah's Witnesses.
Yes.
Mm-hmm.
And but it said in there that the Big Bang was consistent with Genesis.
Ah.
It was kind of like there was nothing, and then God brought into being, and they're not wrong.
Well, there's an argument that could be had that way. There's an argument to be had that way.
All right, so
Okay.
what I wanted to discuss is, are you coming with me to the Kingdom Hall Saturday?
No.
Okay, all right.
All right, so Ruby Redbird. This is a friend says that he loves this,
Okay.
and I haven't. It's been a long time. I haven't tried it, so I wanted to get into it. It's from Shiner, and it's low alcohol, low calorie, and it's got grapefruit and ginger.
And low carb.
Yeah.
I mean, not low carb, but low carbonation.
Oh, yeah, and I didn't get much of a head
No. Okay.
when I poured it.
And-
Ooh, I get a little bit of grapefruit flavor in there. I'm not sure I'm tasting. There's the ginger. The ginger just kind of came to me. Yeah.
Yeah.
Yeah. Okay.
There's both. And
Interesting. It's a good summer kind of a drink.
So it's only a 3-2.
I know,
So,
yeah.
Yeah, you're out there.
Easy drinking.
Working a chainsaw in the yard. You don't need. you don't need to get hammered.
No, you don't.
So,
Okay, Shiner Ruby Redbird. Try it if you like light, refreshing summer kind of a beer. There you go. All right, so the Big Bang.
Big bang, bing, 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 bang. So the Big Bang. When did people start talking about this, and what were they thinking before? Everybody had just the universe is eternal, and it's just always been there, and just doing what it does.
Before the Big Bang, the main theory was the steady state universe.
Okay.
But George Lemaitre, I don't know how you pronounce it, a Belgian priest, astronomer, and professor of physics, came up with the Big Bang theory. And he didn't call it the Big Bang theory. He called it hypothesis of the primeval atom.
Yeah, that's not
because the idea is that the whole universe was squeezed down into a teeny tiny little atom.
And so, as a religious man, there was nothing, again, just like the Jehovah's Witness, inconsistent about this science and
The idea of the world having a beginning is clearly something that
it's right there.
Yeah,
This was 1-1.
Yeah, exactly. That somebody would think this is a good idea. Now, Fred Hoyle was an advocate of the steady state theory, and he ridiculed Lemaitre's position as the Big Bang. But that stuck.
It did stick, and everybody seems to like it.
Yeah. And it makes a lot of sense. You have this teeny tiny little thing, and all of a sudden, kaboom! You got a universe. It's Big Bang seems to be an appropriate name for it, but it raises lots of questions.
Yeah. So the steady staters were. So what year did you say?
1920s, late 1920s.
All right. So I mean, we had to have some reasonably good telescopes.
Yeah. So Edmund Hubble. So I was wondering, what were the things that Lemaitre saw that made him speculate on this idea of a Big Bang? And one of them was that the universe is expanding.
Exactly. That's exactly where I was going. I was like, we had telescopes enough to say. So then you're just like, well, if you rewind the film, I don't know. It's a pretty reasonable conclusion.
Yeah.
Right.
So one of the things that we know about the universe expanding is what's called redshifting. When you look at things that are far away, they're redshifted. So you know that light, like if you put it through a prism, it breaks up into different colors.
Okay.
Right? And one of the things that used to confuse me about that was, wait a minute, all light travels at the same speed. So why is like the red light coming at a different speed than the blue light? And that's not the right way to look at it. The right way to look at it is it's the wavelength of the light. And if the wavelength gets stretched out or gets compressed, that changes the color. It's still going at the same speed.
Okay.
So the idea is that the wavelength of the light from far away is being stretched out, so it gets red shifted. It looks red. And the weird thing is, the farther out you go, the more red shifted it is, which means things are farther away, are going away from us faster and faster.
So it isn't simply expanding at its inertial rate. It's increasingly.
Well, I'm not
expanding.
sure that Lemaitre knew that. I think that's a relatively more recent discovery. That not
Which doesn't
only
make
is it
sense
expanding,
to me. I mean, if it maintained its speed because there's nothing to slow it down, or whatever the initial, when a bullet comes out of the gun, whatever that muzzle velocity, if it stayed like that in space, that's fine. Why would it get faster?
I don't know.
Yeah.
I'm not sure anybody knows. But apparently the universe is expanding faster and faster all the time. So what Lemaitre basically said was, okay, well, if it's expanding, then yesterday it had to be smaller.
Yeah. Yes.
And
exactly.
50 years ago, it had to be smaller still, and 1 billion years ago, it had to be smaller still. And he worked it backwards to, okay, it had to be compressed. Now, it wasn't
singularity.
just, right, and it wasn't just that. He also worked on some of Einstein's general relativity theories, which I don't understand.
Right.
But so working that and the redshift and all the other kind of things together, he came up with this idea of the singularity, a point where the entire universe was compressed in one little pinhead.
I got a problem with this.
Yeah, I know. It's
So I asked ChatGPT, I said, if a proton was the size of a basketball, how far away is the electron?
okay.
And it was 8 miles.
Okay. Right.
So, if you look at, with that in mind, atoms are mostly
Empty space. Right.
And so there's a lot of room for compression.
Yeah.
And if you told me that the Earth was once the size of a golf ball,
Yeah.
With that little analogy, I could probably work with you there.
Right.
But if you're going to tell
The entire universe.
and golf ball doesn't even come close.
Right. So I saw this chart today showing the size of our sun compared to the size of other suns.
Yeah.
And it shows this big sun like the size of a basketball, and then our sun is like this little pinprick over to the side.
And our sun is like 90% the size of the entire solar system.
Yeah. So our sun is completely huge compared to the Earth, but it's nothing compared to other suns out there.
Yeah, so how are you getting all of this mass down to an
you're getting it
infinitesimally
all
small?
down, crushed down. It doesn't make any sense to me either. But that's the way it
how it goes. They're going. I mean, like you said, if you rewind it and you start going backwards, well, that's where you end up, right?
So this whole concept of the Big Bang became pretty well accepted. Although nowadays there are a bunch of other theories. Like once you get back to, so here's a problem. Like we had Newton's physics, which explained things pretty well in the world that we know, and we could put people on the moon, and we could send probes to Mars and Venus.
Exactly. We can predict when Halley's Comet is going to pass through the neighborhood again, and that's just basic Newtonian physics.
Yes,
Nothing
and
wrong
all
with
that, it works perfectly well until you get to things going really fast or that sort of stuff, and that's when you need
supermassive black holes.
Right. That's when you need Einstein's general theory of relativity. So, general theory of relativity helps us understand a whole lot more, but even that breaks down when you get back into this Big Bang stuff.
Well, yes, because then that is for super large bodies.
Yeah.
Don't seem to act quite right according to Newton. So you need general relativity, and then isn't that where you get quantum mechanics? When you get to subatomic levels, then things stop acting right.
Yeah. So the way molecules behave, it just doesn't work with Newtonian mechanics, but it does work with general relativity.
But that's the world you're living in when you're talking about compressing the entire universe down to
and other things start to get spooky too, like time. One of the weird things about general relativity is when you go faster and faster, length gets shorter and time gets slower and all kinds of other bizarre things. So when you're dealing with really, really high gravity situations or other things like that, general relativity works better, but it breaks down also when you get down close to the first few seconds of the Big Bang.
Right. So let's finish with the Big Bang and the singularity, the stuff that I think everybody kind of agrees on.
Yeah. The singularity is the part that they disagree on, actually.
Well, I mean, they're good. Everything after the first trillionth of a second.
Yeah. Yes.
Everybody's pretty good about it. So let's talk about that, and then we'll get to the early trillions.
Most people seem to agree with this concept of a hot, there's a name for it, a hot bang or a hot Big Bang. So people believe in the hot Big Bang, but they differ over the singularity.
Okay, but then you had inflation.
Yeah.
So there's like this first trillionth of a second where everything's at trillions of degrees and traveling unbelievably fast.
Mm-hmm.
And atoms are formed, or not atoms are formed, but
no, atoms don't exist yet.
No, right. They don't exist yet, and somehow they know that. Then within the first half second,
right?
I know.
All of a sudden, there are redheads, right? Yeah, it's just bizarre how they can calculate what happens.
Right, and they said things had not come together for there to even be light.
Yeah.
For 380,000 years. I don't know where they get that number, but everybody apparently is okay with this number.
Yeah.
Which is what? So you finally had enough.
Where you can get a proton or something.
Yes, or organizing themselves into atoms that can allow for.
Yeah. So light. if you take the general statement of general relativity, E equals mc squared, right? Then energy and mass are related, so that energy can become mass and mass can become energy, right?
Okay.
So what we have in the beginning of the Big Bang, as I understand it, is you've got everything compressed down into this teeny tiny spot, and as it starts to expand, all this energy is being converted into mass. So there isn't really any mass for.
I see. Yes.
Right. So this idea of the whole universe being compressed down into this tiny little speck, we think of it in terms of this stuff, all this stuffy stuff around.
Right. Rocky planets being jammed down.
Yeah, and maybe that's not the right way to conceive of it.
I hear what you're saying.
So
you're not even at the hydrogen and helium.
Exactly. You don't have protons, electrons, or any of that kind of stuff. That doesn't even exist yet. So as the universe starts to expand, and somehow this energy is being converted into matter. Yeah. So that's why there isn't any light, because light is a proton, and protons don't exist yet. Right. Yeah, so it's
but the thing is the cosmic microwave background.
Okay, right.
All right. Mm-hmm. So that kind of really nailed things.
Yes. So that was a big discovery. This 3 degrees Kelvin background radiation.
60s, right?
Yeah, something like that. Yeah. And so for those of you who don't know, we generally in America measure temperature in Fahrenheit, and then the rest of the world measures the temperature in Celsius. Kelvin is the same as Celsius, except 0 is absolute 0. So 0 Kelvin is like negative 273 Celsius, something like that. Yeah, so Kelvin is
as cold as anything
you get. That's right. So 3 degrees Kelvin is supposed to be this background radiation all over the universe that's supposed to be a symbol or a sign, evidence of the Big Bang.
And the folklore of it is that these guys could not get rid of that sound, right? And they went out and they said,
like a radio telescope.
I know what it is. It's
the bird poop.
Birds be crapping on this thing. So we'll kill all the birds and we'll clean the thing real good.
And the sound didn't go away.
The sound didn't go away. And they're like, all right. So that's
something else.
The sound of the Big Bang.
Yeah.
That's what it is. Okay. So we're talking about, doing that math backwards and forwards.
Right.
Then when one theory doesn't work, you had a new theory which comes with itself new math.
Yeah.
Then they realized we're missing so much mass and so much energy that they
the dark energy thing.
No.
Yeah.
So now it's like, actually, most of the universe is undetectable.
See, I just have a
Is that
really, I have a
cheating? Is
really,
that cheating?
It does seem like cheating. It
When they
seems
create
like,
a constant, they're like, all right, the math works only if we put 0.002 times everything times 0.00. So we're just going to start doing
we're just
that.
going to start doing that.
Yeah, because then all of our formulas work.
It sounds like the kind of thing your older brother pulls a trick on you. You know. Look, yes, I've only got $10 in my wallet, but I've got $1 million. Believe me, I've got $1 million. It's just you can't see it. It's invisible dollars, and this dark matter stuff. I mean, I'm sure they've got smarter people than I am have reasons for it. But I've always been like, come on now.
I know.
Really, it just sounds like you're making something up to make your equations work.
Yes.
Yes.
But when you do that, then the equations do work,
Yeah.
and they actually are repeatable, and
Yes.
they
And
show
that's the
positive
spooky
results.
thing. And that's the spooky thing about our universe is you have a bunch of geeks sitting in a room writing on a chalkboard, and they're like, "Well, wait a minute. What if we stuck a 5 in there?" and then
that would explain why that universe.
Why
that
that thing
galaxy
over there?
is over there
And why
at
that
that
worked.
speed. All
Yes.
right. Oh, yeah, it works for all of them? All right, well,
now maybe that's right.
that's science.
Well, it's just incredibly spooky to me that these equations, you work on these equations and you play with these equations, and then you find out, oh yeah, that's how the trilobite shell works, or something. It's just really amazing.
All right, so believe it or not, this is the stuff that everybody does agree on.
Yeah.
Weird. But then, like, when you back yourself up to, well, what about that trillionth of a second before the Big Bang?
Yeah.
What was going on?
Yeah,
And
so
that's where...
where it gets complicated. So when people ask the question, what happened before the Big Bang, there's a kind of a threshold issue, which does that question even make sense? Right? So it's in a sense, it's like asking what's north of the North Pole. It's a stupid question, because from the singularity perspective, there is no before the Big Bang.
Time itself.
Time itself didn't exist. So the idea of saying what came before when time happened, that's obviously dumb.
Right, so you go into a room and there's nothing in the room. You say, what's in the room? Nothing. That's not the kind of nothing we're talking about here when you say something coming from nothing.
Right, so that
unless you go, but that's nothing is not really what you're thinking of. It's not an empty room.
So
this is really nothing.
This is where it gets really, really complicated, and there's all these different theories about how to explain. Either it's the singularity, where there's nothing before it, and all of a sudden, kaboom! There's a universe, or there's a bunch of other explanations, like the oscillating universe, or this. That Hawkins theory we were talking about before, where space, like now we have space and time, and at some point you didn't have space and time, you only had 4 dimensions of space.
Yeah.
So there are a bunch of other ways to deal with that question, what came before the Big Bang. And this is why I think I'm going to channel Edward Feser here for a minute. Edward Feser is a Christian philosopher who studies Aquinas. And a lot of people get hung up on this question of, well, what caused the Big Bang?
Right.
What was before the Big Bang? And they think that that's some sort of a slam dunk for the existence of God, because obviously God had to cause the Big Bang. And Feser would say, you're missing the point of the argument. That's not the point. The point is not temporally there was nothing and then there was something. Because that's just a stupid question.
That nothing created something.
Yeah. So he's not talking about that. He says what Aquinas is talking about is you have a train going down the track, and this car isn't, the coal car isn't making the train going down the track. What's pulling the whole thing? So from Feser's perspective, the question of what is the cause?
First cause, prime mover.
Yeah, all that kind of stuff. It's not a temporal thing. It's not what was before. It's a question of what is the thing that makes all this possible? What is it? What's the underlying reality that pushes this forward? And that gets into what you were saying about this nothing. There are some people will say, well, you can't get something from nothing. And other people say, oh, well, you can get something from nothing if there are quantum fluctuations in a bubble universe. Well, you didn't start with nothing.
Yeah.
You started with this concept of quantum fluctuations in a bubble, right? So that problem of what did you start with? What were the original conditions? Why was it that the Big Bang happened? There are a whole bunch of different theories about how to answer that question. So when people get a little, I think sometimes Christian apologists get a little too up on their high horse and think, we got you trapped here.
Right, because they assume that you are married to something came from nothing, and I gotcha.
Yeah, and that's not true.
Right.
Physics is not married to this something came from nothing.
Yeah.
Because I think physicists are smart enough to realize that doesn't make much sense.
Yeah.
You can't get something from
right,
nothing.
and so then you would make then the argument is the apologetics view. What sounds weirder to you? That something came from nothing, or that there was a supernatural force that made it all happen? Isn't that actually a better explanation? Yeah, I mean, in that sense, it kind of is. Yeah.
I guess the question that seems bigger in my mind is all of these different theories. All the Big Bang theory, the hot Big Bang, the alternative cosmological models, all these different things that we were looking into. All of them seem to presuppose math and physics and rules and logic and all that kind of stuff. And to me, the bigger question is, well, where did all that stuff come from?
Right.
Where did we get the idea?
Were the laws of physics born in the thing? Well, this is why, yeah. So, with that in mind,
that's fine, yeah.
Then I want to get to the fine-tuned universe,
okay,
and the four fundamental forces.
Okay.
So what are the four fundamental forces? Electromagnetism,
gravity,
strong
and weak interactions, right?
Yeah. Strong and weak nuclear forces. So the argument is
there are more in terms of the fine tuning. There's more pieces than that, but yeah.
But that it presupposes that the Big Bang is a one-off event, and the universe is so finely tuned.
Yeah.
That if gravity was a little bit weaker, or if the electromagnetism was a little bit stronger, or whatever, the universe would not hold itself together.
Right.
And so, how is it if there was no guiding hand in this, that on your first shot
you get it right
it right, and all of the laws of nature are understandable, and all are born in the same spot? I think, which is where you get your multiverse.
Yes. Well. Okay.
Yes. You know where I'm going, but
I know where you're going. So the point of the fine tuning is that there are all these things. Like there's stuff about the nature of water. Like if water was a little bit different than the way it is, there couldn't be life.
Yeah.
There are things about all these different sorts of constants that if they were just a little bit different, life would never happen. So people say, isn't that an example of fine tuning? And I guess I have a couple reactions to that. One reaction to that is, how the heck do I know the relationship between all these different things? Like you're saying that this thing has to be fine-tuned just exactly so. Well, how do you know whether it's even possible for it to be
not
10% less or 20% more?
That was one of my reactions was maybe the fact that that's the only way the singularity would ever happen.
Yeah.
So yes, it only happened once, but it would never have happened if it wasn't already built into the cake.
Right, because we don't know. Like we were talking before about what were the rules that existed before the Big Bang, right? For the Big Bang to happen, for the hot Big Bang or the singularity or the whatever, there has to be some set of rules by which things behave, right? And then we're going to start talking about those rules and say, gee, they're just so fine-tuned. How do we know? I mean, maybe that's just the way the rules have to be.
But the other one is the multiverse, or the repeating galaxy,
right?
So that with every singularity that doesn't have the proper fine tuning,
it just falls apart.
It collapses on itself, and you get a new one or whatever. And so it sounds really hard to think that you could roll 100 dice and get all ones. But if you had infinity to do it,
yes,
eventually it would.
Yes.
And so that ends up creating the only universe that we could possibly experience. And so, it wasn't very rare, but it's what created time itself.
And what you get out of that is somebody will say, you're just making up this multiverse stuff because you're trying to avoid God in the fine tuning argument.
Yeah.
And I have some sympathy with that with that argument that okay, but the only reason you're saying that is because you don't want to believe in God. So when we present this fine-tuning argument, you're going to say, no. There's a billion universes, and this one just happens to be fine-tuned, because if it wasn't, then we wouldn't be here to be talking about it.
Yeah.
And I get that point. That's a decent point. But I don't think that the evidence for the multiverse is necessarily tied to that. There's apparently, according to people who know a lot more than me, than I do, there's other reasons to believe that the multiverse might exist, other than just let's make up an excuse to avoid fine-tuning.
Right, but in my example, it's repeating universes one after the other. But then there's the bubble universe, so that if you look at a bubble bath, you wouldn't be able to experience any of the other bubbles.
You're in one of the bubbles, right?
You're in one of the bubbles, and you're experiencing all the rules. The rules
in your bubble.
They have different rules, so whatever's going on over there is impossible for you to recognize.
Because let's get to that point, because one of the weird things about the universe is that you can't go find the edge of it. Right?
But if you have an explosion and you go out and you knew that somebody had laid some dynamite in a field,
right?
It would be easy to find the center of it. You look at the
firemen
debris.
Do it all the time. Yeah,
the debris goes in all directions. You're like, okay, this is where it starts. Why can't you do that with the Big Bang?
Yeah, because the universe is boundless, which is and it's a very hard concept to get because.
Yeah, it is.
But if you imagine it this way, if you're standing on the Earth, then the Earth goes out in all directions from you equally, no matter where you are standing on the surface of the Earth, right? It's 7,900 miles that way, and it's 7,900 miles that way.
Right. And the guy on the other side of the Earth is saying the same thing.
Exactly. Yeah. So the universe is unbounded, meaning that there's no end to it. There's no edge to it. You can't say, if I go that way forever and ever, I'll finally find the edge. No, you'll just kind of come back around again.
And then you'll poke your finger through the edge of the
universe and find some peanut butter on the other side.
See what's out there.
But that's not the way it works. So when we think of a bubble bath, it is at least conceptually possible for the little ant inside this bubble to come out and go into the other bubble. But we can't escape this universe. There's no edge, there's no boundary, there's no way out of it. So all these different other universes would be existing completely independent of us. We couldn't know anything about them.
But all right, so there are two ways. I'm thinking that these other universes are failed, non-functioning universes as far as we're concerned. But then there's the idea that they're exactly like this, except for I'm 7 feet tall. I mean, right there would be one thing, everything about the universe is exactly the same. Yeah. And if there's an infinite number of them, then all it would take is one ant going in a different direction to create it.
Yeah.
I'm having trouble with that.
I know. Well, all these things become so big and so way beyond our experience that they're very hard to conceptualize. But this idea of the multiverse, I think a lot of times Christians get upset about the multiverse and they think, oh, you're just trying to get away from the concept of God. But, I'm not so sure, because think about how big our own universe is. And there's billions of stars and billions of planets and all this kind of stuff. And you're saying God created all this huge, monstrous thing just so that there could be life on this planet.
This insignificant little speck at the edge of a spiral, insignificant galaxy.
Why is that any harder than saying God created a billion universes?
What's all the rest of it for? I mean,
this universe could be the one where life happened.
But not even just barely in this universe, on this tiny speck in this universe, and in this galaxy. Yeah. And what's all the rest of it for?
Right.
Is God just digging the light show?
Did it take rolling 20 gazillion dice to finally get the one that we wanted? So you had to create 20 gazillion galaxies and universes and everything else.
To finally get somebody who will worship me. Because I'm bored.
To finally get this one where we can be sitting here in Ben Franklin Studios drinking Ruby Redbird and talking about the Big Bang. Yeah. So I don't know.
I don't know.
But it was interesting in that podcast we were listening to, where Michael Shermer was interviewing those two guys.
Right.
What were their names? Niash.
Yeah, an
Ash
Iranian
40
guy who grew up in the theocratic.
In Iran.
Yeah, and then comes out and escapes and becomes a cosmologist.
Yeah, pretty cool. And Phil Harper. And those guys were really smart and really interesting. And they talked about there's consensus over this idea of the hot Big Bang, but there isn't consensus over the singularity. Right. And they described a bunch of the other different possibilities, and it was really pretty fascinating.
It was.
Yeah.
It was, yeah.
Yeah.
Apparently a book which probably need more of books that are technical but accessible to just the lay,
right? Because
science fan.
Once you start getting into all the math and stuff, I mean, I'm decent at math, but not that level of math. When you get into that stuff, you're beyond me. I didn't even get into differential equations in college, so I'm not going to understand the relativity stuff. Yeah. So there is no consensus on what happened at or before the Big Bang. There is consensus that there was inflation, there was something sort of like a hot Big Bang, but they don't know what happened before it. They also got into a discussion of time travel, which I thought was a little
that was
interesting but kind of silly.
A little bit off topic but sort of we've had some fun with the idea of time travel, but just why mathematically it's impossible.
Right.
Yeah, because why time has to be unidirectional.
Yeah. And they said somehow that in the equations you have to assume that or things fall apart, which I thought was very interesting.
Right.
Yeah. Right. All right, so the Big Bang, there was nothing before the singularity, but there might have been something before the Big Bang. I guess that's the
is it true that our whole universe was in a hot, dense state nearly 14 billion years ago? Expansion started. Wait.
What is that?
That's the opening to the Big Bang Theory show.
Oh, I never watched that show.
You never watched that show?
I never watched that show.
Weirdo.
Oh, sorry.
Yeah.
Cheers. Thanks so much for listening to Beer and Conversation with Pigweed and Crowhill. Remember to visit us at pigweedandcrowhill.com or send us an email at pigweedshow@gmail.com.